Hello. In the previous class, we discussed something called Sturm Liouville theory, and we saw how orthogonality relations for second order differential equations could be arrived at. And we also saw that certain differential operators are not Sturm Liouville type, and to convert that differential equation into Sturm Liouville type problem, you have to multiply those differential equations with a weight factor. This we saw before, and suppose a differential equation has to be made Sturm Liouville type, and assume that g of x is the factor which is to be multiplied throughout, and this is how you can convert your uh, differential equation to Sturm Liouville type. So this is a Sturm Liouville type differential equation. And when your differential equation becomes like this, obviously the relation from where orthogonality condition can be obtained, that will also be altered by this weight factor. So you see that within the scalar product you have this weight factor g coming in, and this is the boundary term within the limits a to b, and orthogonality condition can be arrived at by assuming that the boundary term vanishes at the limits. That's how we arrive at the boundary conditions. That's how we arrive at the orthogonality relation by making this boundary term 0. Suppose we consider a specific case, that of Hermite differential equation, and there you see that the weight factor that is to be multiplied is e raised to minus x square. And if you write down the boundary term, it will be something like this: hn star x e raised to minus x square hm prime x minus hn star prime x e raised to minus x square hm of x, where hn of x and hm of x are solutions to Hermite differential equation. And this term, if you look at this term, this vanishes at two different possibilities. One is at x equal to minus infinity, and the other is at x equal to plus infinity, because at both these cases e raised to minus x square happens to be 0. So the boundary term vanishes at x equal to minus infinity and plus infinity. So the limits of integration, so the scalar product will get it as, or the orthogonality condition will get it as integral minus infinity to infinity e raised to minus x square h m of x hn of x dx equal to 0.